Hello. This video is for the Algebra 1 textbook, Chapter 4, Lesson 1. The lesson is titled Graphing Relationships. The objectives to this lesson are to match simple graphs with situations and also to graph a relationship. The vocabulary for this activity is continuous graph and discrete graph. All right, so who uses this? Well, cardiologists can use graphs to analyze their patients' heartbeats. We'll see an example of that in example 2. Graphs can be used to illustrate many different situations. For example, trends shown on a cardiograph can help a doctor see how the patient's heart is functioning. To relate a graph to a given situation, use keywords in the description. So here in example 1, we'll be looking for keywords in the description, just as they mentioned down here in this part. So let's go ahead and read the problem first, relating graphs to situations. The air temperature was constant for several hours at the beginning of the day, and then rose steadily for several hours. It stayed the same temperature for most of the day before dropping sharply at sundown. Choose the graph that best represents this situation. So we have three graphs here, graph A, B, and graph C. It says step 1 is to read the graphs from left to right to show time passing. So we have a horizontal line here. This is the x-axis. Let's go ahead and mark that, kind of get used to the idea of the x-axis. So the horizontal line is the x-axis, and the vertical line is known as the y-axis. And in the beginning, right here, where we have the two of them meet, where the value of x is 0 and the value of y would be 0, this is known as the origin, or G-I-N. I don't know if I spelled that correctly. I'm a good math teacher, just not much at spelling, but that's known as the origin. So whenever I refer to the origin, I'm talking about where x is 0 and the value of y is 0. It's where the two uh, axes cross each other, where their values are 0. So it says to read the graph from left to right to show the passing of time. So as we start from the origin and move to the right, from the left to right, this is time. As time increases, all three of them are the same way there. Step 2 is to list keywords in order and decide which graph shows them. Let's go ahead and grab this highlighter here. What color I got? I got green. Let's go ahead and go with we'll try a yellow. So the air temperature was constant for several hours. So was constant. That is some keywords right there. And at the beginning of the day, then the day, and then rose steadily. So rose steadily. Here's some keywords right there. It stayed the same temperature. Stayed the same is key for most of the day before dropping sharply. Dropping sharply is also key at sundown. So we can see those all here in our, I'll grab the flashy red thing here. So we can see was constant, rose steadily, stayed the same, and dropped sharply. Then we have a segment description. So each of these segments as they change, we got this straight going across line. Then we got a quick swing up, quick curve going up, and then it comes down quickly, and then another horizontal line. So on each of these, same thing, horizontal, quick curve up, steady line across, sharp drop, sharp steep incline, horizontal steady, up, and then a quick drop. So which one, let's go ahead and see which one matches. So we're going to start off with was constant. So was constant means that it'd be horizontal. So the temperature staying the same. As time increases, the temperature staying the same, and it because the temperature was constant. Well, we have here where we start off, and it's just going across horizontally on A, also on B, but not so much on C. So we could go ahead and rule C out. And we see that from our example here that graphs A and B are possible answers. The next keyword is rose steadily. We'll show that by a quick slanting up. So as time increases, right, we should see the temperature going up steadily. So we've got this up steady here and this up steady here. And we've already ruled out C, so it could be A or B still. Let's continue to look at our keywords here. Stayed the same. Well, stayed the same, right? Is the same as being constant, so we should have another horizontal line. Well, on graph A, we see it goes up and then it starts dropping again real quickly. But on graph B, we do have a horizontal segment here where it is staying the same. So we can pretty much realize that, find my red pen, It looks like this is going to be the correct one, so we can rule out A. Let's go ahead and check that last phrase as well, see if it holds out as being true, and then drop sharply. Do we have a sharp drop here? Indeed we do. That would be slanting down, so we still have graph B. So step 3 is to pick the graph that shows all the key phrases in order. We have the red, horizontal, right, staying steady or constant. Rising steadily is the blue upward swing that we see right here. Then being horizontal, that's staying the same once again, like being constant. And then a slanting downward that shows dropped sharply. So as we can see, graph B would be the correct answer. So let's go ahead and move along to our next page here. As seen in example 1, some graphs are connected lines or curves called continuous graphs. So as we look back here, we see that this is a steady line, right? It's a line, it's a curve, it's all connected. It's either a line or it is a curve, but everything's connected. It is indeed continuous, so it's known as a continuous graph. Some graphs are only distinct points. These are called discrete graphs. The graph on theme park attendance is an example of a discrete graph. It consists of distinct points because each year is distinct and people are counted as whole numbers only. You can't have 1 3/3 of a, or 1 3/3 you could. You couldn't have 1 1/3 of a person. You either got one person or you have two people. The values between the whole numbers are not included since they have no meaning for the given situation. If I take a line here and we read the number of people and we go across, let me make this line maybe blue since we got red dots. If I got a line that goes across here, let me see if I can grab that line and move it. There we go. So there are points where this is a certain number of people here, and this is a certain number of people here. It's all matching up with that horizontal line, the y-axis, which is the number of people. And in between, there would be places where as we go from a high number of people and we get a lower number of people as we move along through the number of years, there are going to be points that if it were a line, we could actually find a point where we have 250.6 people. Well, we can't have 6/10 of a person. That's not going to work. So in this case, we are talking about a distinct graph because the dots actually represent a situation. So let's go ahead and look at our example 2, sketching graphs for situations. Sketch a graph for each situation. Tell whether the graph is continuous, that would be solid lines and curves, or discrete, that would be connected with dots, or dots along the line. So Simon's selling candles to raise money for the school dance. For each candle he sells, the school will get $2.50. He has 10 candles that he can sell. So let's go ahead and make a graph. Every good graph has a title, Simon's earnings. So the amount earned is the y-axis. Here's the y-axis. It's the amount earned. It increases by $2.50 for each candle Simon sells. That is the x-axis where we list the number of candles sold. Since Simon can only sell whole numbers of candles, the graph is 11 distinct points. You like 10 candles, why 11 points? Don't forget, we also have where he has sold 0 candles, he has $0, so we could graph that. After one candle, he's got $2.50. After 2 candles, $2.50. After, or $5. After 4 candles, he'd have 10, and so on until he finally sold all 10 of them. He would have $25. The graph is discrete because it's not a continuous line. It's just discrete points, each point representing a candle and how much that Simon has made so far. Angelique's heart rate is being monitored while she exercises on a treadmill. While walking, her heart rate remains the same. As she increases her pace, her heart rate rises at a steady rate. When she begins to run, her heart rate increases more rapidly and then remains high while she runs. As she decreases her pace, her heart rate slows down and returns to her normal rate. So as time passes during her workout, that is our x-axis here. Look, they've even labeled them for us, x-axis and y-axis. And our y-axis represents the value of the heart rate. So remains the same is the red. See the red here and the red here. So remains the same. It's going to be horizontal. As time passes, it's going to stay the same. It rises at a steady rate. Starts to rise a little bit right here through this blue part. Increases more rapidly now that she starts running. Her heart rate increases. And then while she's running, her heart rate remains high, which we see in the purple. Then she stops running, her heart rate starts to slow down. We can see that in the gold, and then returns to her normal rate, which is like this light teal color here. So in this case, we have a continuous line and curves, so it is a continuous graph. Let's move along and look at the next slide here. When sketching or interpreting a graph, pay close attention to the labels on each axis. So the labels that we see here on the horizontal x-axis and on the vertical y-axis, they do make a difference. Both graphs below show a relationship about a child going down a slide. Graph A, we have here, always have a title on a graph, represents the child's distance from the ground. And the graph B represents the child's speed over time. Notice both of them are measured. The x value is measured in time on both of them. However, on graph A, we're measuring the distance from the ground in relationship to time. And here on graph B, we're looking at the speed that the child is going in relationship to time. Let's go ahead and look at graph A first. So whenever time is 0, the child is high up off the ground. And that makes sense. You're at the top of the slide, getting ready to slide down. You start to slide down, and as you slide, you start getting closer and closer to the ground until you get to the bottom of the slide, and then suddenly, feet dangling off the end of the slide, assuming it's a small child, then they jump to the ground, and now they are at the same level of the ground. Start at the top, high above the ground, and ended down, touching the ground. Now, graph B is a little different. Whenever they're at the top of the slide, getting ready to slide, where time is 0, they're not have no speed at all. They start to edge off the slide, and as time goes, their speed speeds up a little bit. Then whenever they get to that steep part of the slide where they get to the ground faster, their speed's going to speed up, and then it's going to start to become steady as they get into this part right here, getting closer to the ground, and then it's going to just go ahead and then drop real quick because as they jump off the slide, well, gravity's pulling them to the ground quickly, so their speed as they travel is going to be quick, even and it's a short jump, so that's why it goes down so quick in such a short amount of time. Example number 3 is writing situations for graphs. Write a possible situation for the given graph. Here we have time. Here we have water level. At the beginning, the water level is 0 at the beginning of time. It fills up quickly, and then it stays at the same level for a while, and then it empties quickly. So step 1, identify the labels. We did that. The x-axis is time. The y-axis is the water level. Analyze the situation. Well, over time, the water level increases steadily. Then it remained unchanged, and then it decreased steadily. Possible situation. A watering can is filled with water. Stand at the spigot, fill it up pretty quick, fills up quickly. It sits for a while, so as time passes, the level stays the same. It sits for a while until some flowers are planted. And then it's emptied on top of the planted flowers. So then somebody waters the flowers, pretty much pouring it out just about as fast as it took to fill it. On the next slide here, we have our guided practice. Vocabulary. Apply the vocabulary from this lesson to answer each question. A blank graph is made up of connected lines or curves. Is this continuous or is it discrete? Well, the key phrase here is that they are connected lines or curves. So we do have lines, and we also have curves. So altogether, that is a continuous graph. Think of it this way: the line continues. It doesn't like start, stop with the dots. A blank graph is made up of only distinct points. Well, that's that dotted one, right? So that would be which type? Indeed, it would be discrete. If it has dots, it's discrete. If it's lines and curves, it is continuous. Example 1, choose the graph that best represents each situation. So we have 3 situations, item 3, 4, and 5, and graphs A, B, and C. So person alternates between running and walking. Well, we see here that we're walking. This is time and this is speed. So as time passes, speed stays the same. Then over a short period of time, it gets faster, and then it gets slower, and then it gets faster, and then it gets slower. So it looks like B is going to match up the 3. So let's go ahead and match this up to item number 3. And I'm going to go back to red. Try to trace over that. There we go. So number 3 belongs to B. Now, what do you think 4 belongs to? Well, a person gradually speeds up to a constant running pace. Well, that looks like A, right? As time passes, gradually speeds up, and then their speed remains constant. So it looks like this is going to be item number 4. And that means that C must be what? Yep, that would be right. Number 5. Let's go ahead and read it just to double check. A person walks, gradually speeds up to a run. They're walking, gradually speeds up to a run, and then slows back down to a walk, and then immediately slows back down to a walk. Indeed, it looks like 5 belongs to C. On this one here, Maxine is buying extra pages for her photo album. Each page holds exactly 8 photos. Sketch a graph to show the maximum number of photos she can add to her album if she buys 1, 2, 3, or 4 extra pages. Tell whether the graph is continuous or if it is discrete. So I need to go ahead and make a graph. So a graph is going to have a vertical axis and a horizontal axis. We're going to label that as not Y. Let me find my eraser here. If you're thinking that should have been X, you would be correct. And this one here would be Y. Now, I do know that the X is what we refer to as the independent variable and Y is the dependent variable. One causes the other. We'll get into that in a later lesson. However, the number of pages that she buys determines the number of photos she can have. So in this case, this is going to be pages. We want our x-axis to be the independent variable. One causes the other. And this is going to be photos over here. And let's see, we'll title this number of pictures. Number of pictures. We'll just do pics. So the number of pics is our title. And we have here an extra 1, 2, 3, or 4. So 1, 2, 3, 4. We'll let that represent the pages. And there's 8 photos on each one. So let's go ahead and let's think of this as in increments of 10. We'll do 10, 20, maybe 30, 40, and I think we should be good there. I don't think we'll get over 40. And so if she has one page, right, she can put 8 photos in, so we'll plot that. If it's 1, then 8 pictures. 2 pages will be 16. So that looks about like 15, maybe about 16 right there. If it's 3 pages, well, at 8 each is going to be what, 24? So we'll go up here right about to what looks like it would be about 24. And if she has 4, 8 and 8, 16, 6 2 is 32. So we're looking at 32. Full 4 pages would give her about 32. Well, our graph has dots, right? It's not a continuous line. So in this case, it would be a discrete graph. Write a possible situation for each graph here. Well, let me see. We have time and we have speed. We start off that the speed is staying constant as time increases. The speed is not increasing or decreasing, it's constant. And then it slows down steadily, right? At the same rate of speed over time. Let's say the train's coming into town at a certain speed. It needs to stop in town, so it just kind of coasts to a nice even stop. So we could say that's number 7 could be for a train. Number 8, I had a hard time figuring this one out. If it's like as age increases, your height increases. And I thought about maybe a child, right? As a child starts to grow, but a child's like never 0 in height, right? So it would be up a little bit and then maybe a growth spurt and then level off, and then keeps growing. I mean, by the time you go through a growth spurt and you like hit what, 18, 19, 20 years old, you're pretty much the height you're going to be for the rest of your life. Maybe a plant. Plant starts growing. Plants, you put the seed in there in the dirt, it starts to grow, and then you get some nice weather and it grows real quick, and then it gets some bad weather and it just kind of stalls for a bit, and then the weather comes out, it's nice again, and the plant starts growing again. So maybe number 8 could be a plant. And then calories. I've got one in mind, but people could argue with it. I'm thinking as the number of servings increases, the calories increase. And let's say that this is a situation where if you give a kid a candy bar, he's going to eat the entire candy bar. He's not going to eat half a candy bar. He's not going to eat a fourth of it. You give the kid the candy bar, he's going to eat it. So give him one candy bar, eats a certain number of calories. Another one, and notice that it's increasing at pretty much the same amount each time. If the kid's not eating 1.5 candy bars, he's not eating 3 1/3 candy bars. So we want to have anything between the 3rd candy bar and the 4th candy bar. So this would be a continuous graph. And maybe it's all about some kid eating a candy bar. All right, so that's all I've got for Algebra 1, Chapter 4, Lesson 1, Graphing Relationships. It was all about matching simple graphs to situations and graphing relationships. Key things are identify key terms such as was constant, rose steadily, stayed the same, dropped sharply. And also we had that whole thing about continuous. These are continuous graphs. And then the ones with lines, those would be discrete graphs. All right, so that's pretty much all I got. Now, go level up your learning.